The last 60 to 70 years have been ruled by the information economy, meaning that everything was about to produce information, making information available, and therefore a large spectrum of applications and induced new products were created. Now, with the advent of the artificial intelligence, which many regard as a fourth industrial revolution, we are facing a shift into the knowledge economy. So it's not anymore about producing information and accessing information, but it's about accessing knowledge directly. Information does not equal to knowledge. Information is merely the data we feed our brain, and as with a computer, data must be processed if we want to gain insights. Our brain takes in information as a computer takes in data and transforms it into knowledge. To explain this cognitive process, we can imagine a process that concatenates concept, derives a context, and draws inferences. This schema essentially illustrates the process our brain undergoes to transform data or information into knowledge. Conceptual representation and semantic context are part of this cognitive process that leads to knowledge. In order to gain knowledge, we need an inferential process, meaning a mechanism that is the building block of reasoning. And an inference can be roughly defined as a logical, conscious or unconscious concatenation of concepts in a given context, where the link between any two of those carry the information element correlating the two concepts. We can access a large chunk of information, but that does not make us any more knowledgeable than any specific subject matter. In fact, information must be read, interpreted, and cognitively understood in order for us to act upon it. First, we have data, unstructured, uncritical. Therefore, data is aggregated and we have information where analysis can be performed. Applying cognitive process to information like inferences leads to the creation of knowledge or the extraction of knowledge. A comprehensive status of knowledge leads to wisdom. Let's start saying that used properly, a knowledge graph provides a framework to extract inferential pathways connecting several objects, taking points of information and turning them into usable knowledge. A knowledge graph is a mathematical framework for dynamically gathering and semantically processing a large amount of structured and unstructured data and information representing multiple subject areas. By mining the sources of information, the platform creates an efficient algorithm-based representation of the overall knowledge it provides, allowing for capturing significant relationships often hidden and semantically quantitatively across various complex data. Instead of basing results of individual elements like a typical database query, it uses algorithms to construct relationships, the graph or network, amongst concepts that are not evident. It shows the relationships between concepts and their connections, derives inferences, and suggests promising areas of intelligence. As a result, a knowledge graph constructed from a large number of diverse information sources and dataset can be used to make predictions, support decision-making efforts, and identify strategies to find meaningful trends hidden within the information. A full-fledged knowledge graph can find correlation across essentially any type of dataset. Doing the kind of inferential work, it might take a full team of analysts with access to a very large amount of data that takes many hours to perform. Knowledge graphs require a flexible structure, a set of dynamic layers that define the set of types, properties, and relationships continuously adjusting as new information comes through. While other graphs map a picture of predefined relationship between entities, those tend to be limited as they can't easily account for the introduction of inferred data from other emerging relationships. Imagine, for example, the relationships that can be dynamically extracted when tracking business interaction between companies. If you have access to certain private database, you can have a supply chain link between any two companies. But such a relationship might not be enough. It is important to understand, on top of all the factual types of relationships that the two entities have in common, like sector or investor relationships or size and market or affiliation, that others can be inferred by second or third order connections. For example, if both entities are exposed to political, financial or geographical risks, a link with such emerging relationship will enrich other existing ones. Moreover, there are relationships that form as an emerging properties of the graph itself. These are defined as emerging inferences. In other words, the amount of information that gravitates directly on or indirectly around any concept mapped into a graph generates an induced ontological, ever-changing layer that dramatically enriches the relationship between any entities of the graph. Knowledge graphs are also actual graphs based on mathematical models, which makes them easily expandable and scalable and allows for application of mathematical graph theory techniques and algorithms like network analysis. That ability to process and interpret plain language is at the cornerstone of what makes them unique. Finally, a knowledge graph is a living organism. Information keeps on coming through quasi real time, and knowledge graph change shape and form, so it's quite important to track the changes at any point in time. Ultimately, knowledge graphs are a framework to formalize and standardize what has traditionally been a unique human problem: the transformation of unstructured and diverse type of information into knowledge. A framework that can be sliced and diced and unfolded even over hundreds of millions of individual objects and across billions of relationships. The intrinsic nature of a dynamic knowledge graph, projecting within their structure billions of relationships across hundreds of millions of data points, augments the capability of investment analysis and researchers by screening more information and finding unintuitive inferences that result in faster and better quality of insights. And it will apply to multiple fields of human knowledge, from life science to finance to geopolitics and even beyond. Additionally, many institutional investors today are seeking more than simple profit. They are looking to make a social and environmental difference, stewarding the financial resources towards an investment that fulfills their purposes and mission while increasing financial returns. The field of environment, social and governance investing, also known as ESG, grow into a full-blown industry, with wealth managers adding ESG advisors to their ranks and companies reporting on their ESG policies. Institutional investors, hedge funds and family offices that take ESG consideration into account are seeking new rating and research methods to guide their decision-making. ESG themes can include considerations like climate change, pollution, health and safety, labor standards, human rights and anti-corruption, etc. To adequately incorporate these considerations into a portfolio, smart investors determine their own ESG thesis and analyze a wide variety of information and data sources for investment fit and profit opportunities.